There's something deeply satisfying about watching skilled craftsmen work with fire and steel, just like the blacksmiths of old. Here at the Czech Republic Forging Association, they're keeping those timeless traditions alive while embracing modern precision. What we're witnessing is a fascinating blend of heritage and technology. The Czech Republic has been a center of metalworking excellence for centuries, and these forging shops carry on that proud legacy. The process begins with carefully selected steel billets, heated in gas-fired furnaces to precisely 200 degrees Celsius. That's about 200 degrees Fahrenheit for us. At this temperature, the steel glows a brilliant orange red and becomes malleable enough to shape. Watch as the forge master positions the heated billet under the power hammer. These aren't your grandfather's hand hammers. These are hydraulic giants capable of delivering 5,000 pounds of force with computer-controlled precision. Yet the skill required is every bit as demanding as it was 100 years ago. The operator must read the steel, feeling how it moves, knowing exactly when to strike and when to rotate the piece. Now comes something particularly interesting: the marking process. Each forged component receives its identification stamp while still hot. This isn't just bureaucracy, it's a matter of pride and accountability. The association uses a specialized pneumatic marking system that stamps each piece with a unique identifier, the shop number, and the date code. This system ensures traceability. If this part ends up in an aircraft engine or a ship's propulsion system 30 years from now, someone can trace it back to this exact moment, this exact forge. The beauty here is that they're maintaining the soul of traditional forging while meeting modern aerospace and automotive standards. It's craftsmanship you can depend on. The Boldrini Portal Frame Press Model PAO 1000X9100 is an advanced machinery that boasts a cutting-edge handling device capable of manipulating cold blanks up to 9,100 mm diameter and up to 90 mm in thickness within the lifting limit of 27 m-tons, hot dishing configuration also available. With an impressive capacity of 1,000 tons, this press is equipped with a CNC manipulator for automation, ensuring impeccable forming quality. As a target result, the PAO press produces heads with a smooth surface and with a regular spherical profile. The manipulator can effortlessly manage up to 27 m-tons, making this press a highly efficient and productive, reliable solution for your dishing needs. Boldrini's high-tech automatic playback system is a proven solution after 3 decades of experience and development in the production of large series of heads. It allows for exact and uninterrupted repetition, ensuring accuracy and efficiency. Boldrini's reputation for high-speed presses is renowned globally. The fast cycling is the real target to cut cost and to produce more material every week. This is achieved with the fastest values of downstroke, compression, and return speeds. Welcome to the Borodai pipe plant in the Almaty region of Kazakhstan, folks. This facility represents the kind of industrial might that built modern infrastructure, and today we're watching them transform massive steel coils into precision square tubing, the backbone of construction projects worldwide. The process starts with steel coils that can weigh up to 25 tons each. These giants are loaded onto uncoiling stations, essentially massive motorized spindles that carefully feed the steel strip into the production line. The precision here is critical. Any irregularity gets magnified down the line. As the steel unwinds, it passes through a series of forming rolls. We're talking about 12 to 16 individual roll stands arranged in sequence. Here's where it gets fascinating. Each roll stand gradually bends the flat strip, bit by bit, shaping it into a circular tube first. This isn't rushed. It's a methodical progression that prevents stress fractures and maintains the steel's structural integrity. The engineers who designed these roll configurations understood metallurgy the way master craftsmen understood their tools generations ago. Now comes the ERW process, electric resistance welding. High-frequency electrical current is applied right at the point where the steel edges meet, heating them to precisely 500 degrees Fahrenheit. At this temperature, the edges become plastic, not melted, but malleable enough that when pressed together by the squeeze rolls, they forge into a seamless bond. No filler material needed, it's the steel welding to itself. This technique revolutionized pipe manufacturing back in the 1950s, and it's still the gold standard today. But we're not done. We've got a round tube, and we need square. The tube now enters the sizing and shaping mill, where specially configured roller dies gradually reshape that circle into a perfect square. This requires immense pressure and precise calibration. Too much force and you'll crack the weld seam. Too little and you won't achieve proper corners. The straightening section uses a multi-roller system to eliminate any bow or twist. These tubes need to be dead straight for construction applications. Finally, flying cut-off saws slice the continuous tube into standard lengths, typically 20 or 40 feet, all while the line keeps moving. Throughout this entire process, ultrasonic testing equipment monitors weld quality in real time, and dimensional gauges ensure every tube meets specifications within thousandths of an inch. It's this combination of brute industrial force and surgical precision that's built everything from skyscrapers to the frames of the vehicles we drive. The Boral die plant processes over 200,000 tons annually. That's the kind of scale that keeps the world building. You know, there's something deeply satisfying about watching skilled craftsmanship meet modern technology, and that's exactly what we're seeing here at the Korkmaz manufacturing facility in Turkey. For over 60 years, this company has been perfecting the art of stainless steel cookware production. And folks, what you're witnessing is precision engineering at its finest. The journey begins with premium-grade stainless steel sheets, specifically 18/10 stainless steel, which means 18% chromium and 10% nickel. This composition isn't just fancy numbers, it's what gives these pots and pans their legendary durability and resistance to corrosion. The heavy-duty hydraulic presses you're seeing can exert up to 400 tons of pressure, literally sculpting flat steel into those familiar pot shapes in a single, powerful stroke. It's remarkable how something so forceful creates something so precise. Now watch closely as the formed pieces move to the spinning lathes. This process, called metal spinning, has roots going back centuries, but modern CNC-controlled spinning machines have transformed it into an art form. The rollers apply controlled pressure as the piece rotates at high speed, smoothing out imperfections and achieving that mirror-like finish we all love in quality cookware. The welding station is where handles meet body, using specialized spot welding equipment that creates bonds stronger than the surrounding metal itself. Each weld point is tested for integrity because Korkmaz knows their reputation rides on every single piece. Finally, the polishing department employs progressive buffing wheels, starting with coarser compounds and finishing with ultra-fine rouge for that showroom shine. Multiple quality inspections happen throughout, ensuring each piece meets standards that would make craftsmen from generations past proud. Now here's a piece of equipment that doesn't get nearly enough appreciation, the humble duct elbow. Every building you've ever been comfortable in owes a debt to these precision-formed components that quietly guide air exactly where it needs to go. What you're watching is the fabrication of 90-degree elbows for commercial HVAC systems, and the machinery involved is beautifully specialized. The process begins with flat galvanized steel sheets being fed into a CNC cutting table. Computer-controlled plasma torches cut what are called gores, those curved, tapered sections that, when assembled, form the elbow shape. The precision is remarkable. We're talking about tolerances within 1/32 of an inch, because even small gaps mean air leakage and efficiency loss. Here's where the magic happens. The gores move to a machine called a gore locker, and folks, this is specialized equipment at its finest. The gore locker has specially designed rollers that fold and interlock the edges of adjacent gore sections, creating what's known as a Pittsburgh seam. This mechanical lock, developed back in the early 1900s and perfected over decades, creates an airtight connection without welding or adhesives. Watch how smoothly those rollers work, bending the metal edges into interlocking hooks in one continuous motion. The operator guides each piece through with practiced precision, knowing that proper alignment now means leak-free performance for decades. The completed seams are stronger than the surrounding metal. They actually reinforce the structure. The formed elbow then gets a final inspection, and sometimes a coating of antimicrobial sealant for healthcare applications.